In this video, we're going to learn about the expectation and the variance of random variables. Last time we have learned about the basic concepts of random variables from this situation. We are given the probability distribution of the discrete random variable x like this. Now let's consider this question. After running this business for 100 days, what will be the average value of x? From the given probabilities, we can estimate this average value. Because the probability when x is equal to 0 is 0.1, so for about 10 days we have x equals 0. Because the probability when x is equal to 1 is 0.6, so for about 60 days we have x equals 1. And because the probability when x is equal to 2 is 0.3, so for about 30 days we have x equals 2. Now to calculate the average value, we can consider there are 100 data like this. And so the average value of x can be calculated by this formula. This is the sum of all the data divided by the total number of data. From this formula, we can see that if we rewrite it in this way, then we can actually compute this average value directly from the given probabilities. In probability theory, this average value obtained from probabilities is called the expected value of a random variable. We can also simply call this the expectation of a random variable. In this situation, this value can be stated as the expectation of x, the expected value of x, ex, or mu. Mu is a Greek letter usually used to denote the mean of a set of data. As a result, we have the following formula of the expectation of x. This formula can be treated as the weighted mean of x with the probabilities as the weights. And this expected value can be interpreted as the theoretical average value of x for a very long period of time. In statistics, besides the average value, we are also interested in the variance of data. The variance of a set of data is equal to the average of the squared values of the differences between each datum and the mean. Similarly, we can see that this variance can also be obtained directly from the given probabilities. And we can get that the variance of x in this situation is equal to 0.36. This value can be stated as the variance of x, VARx, or sigma squared. Sigma is a Greek letter usually used to denote the standard deviation of a set of data, and the variance is simply the square of the standard deviation. In other words, the standard deviation can be obtained by the positive square root of the variance. So we can get that the standard deviation of x in this case is equal to 0.6. Therefore, we have the following formula of the variance of x. We can see that it is just the weighted mean of x minus mu squared. So this formula is equivalent to the expectation of x minus mu squared. On the other hand, if we expand this bracket and expand this summation expression, it will be equal to this. Now this part, the summation of x times p, is just the expectation of x, or mu. And this part, the summation of all the probabilities, is just equal to 1. So this expression can be simplified as this one. And hence we can get that the variance of x is equal to the expectation of x squared minus the square of the expectation of x. This can be understood as the mean of squares minus the square of the mean. Please note that in general, the expectation of x squared is not equal to the square of the expectation of x. Indeed, the expectation of x squared is always greater than or equal to the square of the expectation of x. Now let's take a look at this example. Suppose the probability distribution of x is given by this table. Now we can find the expectation and the variance of x. To find the expectation of x, we just need to add up all the values of x times p. So we can get that it is equal to 2.2. To find the variance of x, we can firstly find the expectation of x squared. To find the expectation of x squared, we just need to add up all the values of x squared times p, so we can get that it is equal to 5.6. Now to compute the variance of x, it is equal to the mean of squares, 5.6, minus the square of the mean, 2.2 squared. As a result, we can get that the variance of x is equal to 0.76. Now let's take a look at some mathematical properties of the expectation and the variance of random variables. Suppose now instead of the expectation of x, we would like to find the expectation of ax plus b, where a and b are constants. To find the expectation of ax plus b, we can still apply this formula of adding up all the products of ax plus b times p. If we expand this summation expression, then we will end up with this expression. Because this summation is just the expectation of x, and this summation is equal to 1, we can get that this can be rewritten as a times the expectation of x plus b. That means if we already know the value of the expectation of x, to find the expectation of ax plus b, we can simply consider this formula to calculate this directly, and there is no need to go through this summation process all over again. Similarly, we also have a formula to evaluate the variance of ax plus b. Using the formula of the variance of ax plus b is equal to this summation. The mean that we consider here is the mean of the variable inside this bracket, which is ax plus b, but not x. So this mean should be the expectation of ax plus b, but not the expectation of x. Usually, mu is used to denote the expectation of x, but not the expectation of ax plus b. So this time I use mu prime to denote the new mean. That means the expectation of ax plus b in this case. Previously, we have just learned that the expectation of ax plus b is equal to a times the expectation of x plus b. So we know that mu prime is equal to a mu plus b. After simplifying this expression, we can see that b is cancelled, and a squared can be taken out like this. For this summation, it is just the variance of x. So we can obtain this formula. The variance of ax plus b is equal to a squared times the variance of x. Please pay attention that this constant b added to the random variable will not affect the variance. So there is no b in the result of this formula. Also, for the constant a, we should take out a squared here, but not a. So this is how we can calculate the variance of ax plus b from the variance of x without going through the summation process again. Now let's consider this example again. Here besides x, y is also a random variable, and it is related to x by this formula. We have already known the expectation of x and the variance of x. So to find the expectation of y and the variance of y, there is no need to consider the summation formulas again. We can obtain these values directly using the formulas that we have just learned like this. The expectation of y is equal to 20 times the expectation of x minus 30, so it is equal to minus 6. The variance of y is equal to 20 squared times the variance of x, so it is equal to 144. Let's have a quick summary. We have learned that the expectation of x can be calculated by the sum of all the products of x and p, and the expectation of x can be denoted by mu. For the variance of x, it is equal to the sum of all the products of x minus mu squared and p, and the variance of x can be denoted by sigma squared. Alternatively, the variance of x can be obtained by this formula, the expectation of x squared minus the square of the expectation of x. And then for random variables in the form of ax plus b, their expectation and variance can be obtained directly from the expectation of x and the variance of x by these relations. Finally, let's take a look at this example. In this example, the probability distribution of a random variable x is given by this formula. In part A, to find the expectation of x and the variance of x, first of all, we need to obtain all the probability values like this. Afterwards, the expectation of x can be calculated like this, and it is then equal to -1. To find the variance of x, we can firstly find the expectation of x squared in this way, and then the variance of x can be calculated by the expectation of x squared minus the square of the expectation of x, so it is equal to 1. In part B, to find the expectation of x plus 2, it can be rewritten as the expectation of x plus 2, so we can directly get that the expectation of x plus 2 is equal to 1. For the variance of x plus 2, this constant 2 added to x will not change the value of the variance. So it is simply equal to the variance of x, which is equal to 1. In part C, to find the expectation of 2x minus 5, it is equal to 2 times the expectation of x minus 5, so the answer is -7. For the variance of 2x minus 5, we should ignore the constant -5 added to this variable. And then for this coefficient 2, we should take out 2 squared. So we can get that it is equal to 2 squared times the variance of x, which is equal to 4. This is how we can compute the expectation and the variance of discrete random variables.